behind, so I'm going to try to move fairly quickly. So Gene's already mentioned what I'm going to talk about here really is what we're calling the phase 2 of this project. Jessica's done a great job introducing a lot of the online content that represents a lot of the deliverables from the first part of the project, the assessment inventory of ecosystem services and environmental threats. And what we've done essentially is kind of identifying what we feel like are some of the greatest needs and information gaps, and moving on with new research to assess ecosystem service sustainability across the Appalachians with regard to various kinds of large-scale landscape stressors or threats. So what I want to really focus in on is the new set of tools we're developing to look at landscape resilience metrics, or develop resilience metrics for assessing ecosystem service sustainability. And this is, like Gene mentioned, is kind of an update from last year's steering committee meeting. So I'll move more quickly through some of these introductory slides and methodological slides in order to have more time to focus on sort of next phase deliverables in the last few slides. So just real quickly, when we're talking about sustainability, we're thinking of the different capacities of different landscapes to provide a variety of kinds of benefits to people, and those capacities vary, of course, with changes in the physical environment, with changes in society, and we're trying to develop tools to better understand the capacities of large landscapes to sustain ecosystem services given these kinds of change. Jessica's already kind of gone over. Let's see. I am now the host of this meeting. I'm going to close this. Is that okay to close this out, Matt? Oh,
what do you mean by it?
Oh, sorry. You're probably not seeing what I'm seeing. I'm going to try to, as long as it's not in anybody's way, I'll minimize that. The recorder became visible for me and it blocked some of the slides.
No.
Anyhow, as long as everyone's fine, I'll just keep moving ahead. So Jessica's shown us the availability of a lot of these data sets we put together, representing the multitude of different landscape scale drivers of change, like urbanization, energy development, likelihoods, climate change. Over on the left, I'm just representing some of this quickly. We know that these are all impacting a variety of important ecosystem services or benefits across the LCC, like the ability of forests to produce clean water sustainably, forest carbon storage for climate change mitigation, the recreational use of outdoor spaces like bird watching and hunting and so on. These categories are really three categories that kind of rose to the top of the list in terms of what we saw as a recurring importance to multiple stakeholders across the region. And I'm going to focus in as an example of the kind of tools we're developing on forest carbon today. So as I said, we know that these, let's see if I can.
Oh. I'm just seeing the first title slide. Is everybody?
Yeah, I'm actually realizing now I'm on the third slide, but I'm not able to forward anymore. Is there an issue with the slides here? Are folks seeing the third slide, which has 6 maps and some photographs on it?
We've been stuck on the title slide.
I see. So I'm seeing the 6 slides, so it must be a buffering thing of the servers. Now I'm back to the second slide.
I flipped back to the second slide and then forward to the slide I'm on to make sure folks are seeing it.
I'm seeing the changes that you're making in real time.
Okay. Well, it sounds like some people may be having some issues. If you're stuck on the first slide and you're not seeing the 6 maps right now, you may want to open up the PDF that Matt sent out yesterday. And I am going to just mention when I change slides so that those folks can follow along. So in the interest of time, I'll just keep moving. Does that sound good?
That'll work.
Yeah.
Okay, so I changed slides to the next one. You should see a landscape resilience title here. And landscape resilience really encapsulates a lot of what we want to try and monitor with the tools we're developing, namely the impacts of various kinds of land use change and climate change and other stressors on the capacity of large landscapes to provide multiple benefits. And so the tools that we've really been developing to try to actually monitor and assess resilience in this sense really focus in on the importance of monitoring disturbance and succession of the vegetation at large scales, because that's where you really see the impacts of, for example, forest clearing, drought impacts, et cetera. All of the different kinds of impact factors are going to be observable if we can look in pretty fine detail at what's happening to the vegetation. So the data set we're relying on it comes from the MODIS satellite, and without getting, again, into too much methods detail here, I'm going to quickly show some illustrations of how we're developing these data sets to eventually arrive at vulnerability assessments for the ecosystem services that are really the focus of the work. So on the upper left here, you can see, well, on both graphs, you can see two different ways of representing the MODIS vegetation greenness data. It's really a surrogate for vegetation productivity at the scale of these 250-meter MODIS pixels. And the advantage of the MODIS data is really the temporal resolution. You can see that we get multiple readings within a year. So we can see high in DVI during the summer, low during the winter, in the case of this one pixel that I'm showing here. We can also see over time land use change impacts. We can see a reduction in productivity and then successional change leading to recovery in the later years. So these are the raw data that we're starting with. And the reason we make these circular plots below is to be able to calculate some basic statistics on these annual data. These plots wrap the years over on top of each other. So we're looking at an annual cycle, and for every year, we calculate the 6 variables on the right here and use those to cluster the data so all the pixels can be mapped in terms of their class. More similar pixels that behave where the vegetation is behaving similar to each other get grouped together. And so within a year, we can then map the different kinds of phenological behavior of the vegetation over the annual cycle. And what that really allows us to do is to get those annual summaries and then stack those maps up. We're looking at 15 years of data here since 2000 to the present, and look at the change over time. When we see large-scale disturbances, they cause a change in the classification of the vegetation. And when we see recovery, that causes a change. So when we group on the left-hand side, I'm now at the slide, we should be seeing on the left-hand side a map with some white hexagons superimposed over these phenoclasses. So those just group landscapes at an arbitrary landscape scale, and we're actually doing these analyses at multiple spatial scales. We can see differences when we change scales, but that just groups several hundred of these pixels, and then we're able to calculate some more statistics from information theory, actually, like the Shannon diversity, which is familiar to ecologists, based on the transitions among different phenoclass types. So what I really just said is we're observing the landscape dynamics and the heterogeneity through space in those dynamics over time. So on the right-hand side, the kind of orange map there on the same slide looks at one of these metrics. This is just the Shannon diversity of the different kinds of transitions that we see in the vegetation. But there are a whole family of these metrics from information theory, like the mutual information, the conditional entropy. I don't want to spend time here, again, too much detail, but I do want to show you some of these maps of these new landscape resilience metrics for the LCC, because they show very interesting pattern. And the point of this next slide, I just changed to the landscape correlates of mutual information slide. That's the title at the top. The point here is just to show that these MODIS satellite imagery derived metrics at high spatial resolution are really encapsulating change over time in the ecosystems that they represent and across space. And they're strongly related to a lot of the more traditional spatial variables that we're used to seeing, like measures of forest fragmentation, measures of, for example, drought variability, but other kinds of climate variability, land cover diversity. So they really are integrating multiple kinds of impacts on vegetation from multiple different sources and summarizing them in terms of the organization and complexity of the landscape dynamics. So again, there's a whole variety of these metrics, and we don't expect any one of them boils down to something called resilience, but that collectively they're able to address multiple kinds of questions that we have about the actual resources that we care about, and they are dynamic over time. So they're not just spatial models. We're looking at them as maps here. I just switched to the conditional entropy slide. We're looking at them as maps, but they're really summarizing the dynamics over time as well as across space. So lastly, I just want to show an example of how we're then utilizing this new family of resilience metrics to examine a particular resource or particular service. So I mentioned carbon storage would be the example I give. Let me just highlight on the lower right-hand side. So this slide shows two green-colored LCC maps on the right-hand side for carbon density. On the lower map, we're looking at the Forest Service's FIA, Forest Inventory and Analysis, estimates for forest carbon density. So these are really tied to the tens of thousands of field plots where carbon storage, among other metrics, get measured directly from the tree censuses that happen on those plots. And so that map is really tied to those field data. Now on the top, we're looking at our MODIS-derived metrics model or predictions for the FIA carbon density estimates. So what you should be seeing is essentially the maps are incredibly similar because with a few of our MODIS metrics, we're able to predict the vast majority of the variability in estimated carbon density across the LCC. So this itself is a nice new product. The point of our ability to move the FIA estimates into the MODIS system isn't just to replicate it. What it is to move it into our dynamic framework over time. And so this next slide gives an indication of why that's important. So I just moved to the slide that's titled Sustainability, Expected Shifts Given the Observed Dynamics. So we're looking at the past 15 years of data, but the data are being collected continuously over time as we move forward into new years of data. And what we're doing across that 15-year time window is looking at all the dynamics that we observe, and these are all basically just based on some fancy matrix algebra. But if you're familiar, for example, with matrix models and population dynamics, population ecology, what you know is that those matrices allow you to project the observed dynamics over the long term to see what you would see if you allow those same dynamics to play out over the long term. So, for example, on the left-hand side, what we're looking at is areas that, given the kinds of dynamics we've already observed over the past 15 years, these are places in darker red that show if we continue to observe those kinds of dynamics, we expect long-term shifts in the kinds of dynamics that we're seeing from current states into new states. So some places show long-term shifts, and other places, even though there is dynamic land use and land cover change going on, over the long haul, those small-scale local changes don't add up to long-term change. It's a dynamic equilibrium. So on the right-hand side, in the green and yellow and pink map, those expected long-term shifts are translated into NDVI changes. So those are vegetation greenness changes. So in the darker green and yellow, we're seeing long-term shift expected towards higher NDVI classes. In the pink and white, we're showing expected shifts towards reduced NDVI classes, and those would correspond to expected long-term changes in the capacity of those landscapes to store carbon, for example. So what I'm not showing here is the full dynamic carbon model, which is ultimately where we're headed with this as a deliverable. Now, all the landscape resilience metrics themselves, and these maps that I'm showing here, for example, these all represent project deliverables, and we expect that they're very useful, not just for one modeling exercise like carbon density, but for a multitude of uses. And we're calculating the metrics at the national scale. So, for example, other LCCs that are interested in pursuing some of this kind of work will have the same data available potentially in the future, right? So, so in many ways, this is our first kind of test case, but the carbon density dynamic model, ultimately where that goes is it shows expected shifts in the sustainability of the resource, right? So places where we expect the capacity of the landscape to be reduced as a result of the different kinds of drivers that we're observing, or enhanced, conversely. So in terms of expected uses, I've now shifted to the final slide that's just a text slide. We're developing tools to monitor and interpret landscape change, and those result in spatial tools, for example, for planning with respect to vulnerability and resilience of various different kinds of resources. For example, now within a planning context, among places that have already been prioritized for conservation activity, we think that the new metrics can really help to identify opportunities for different kinds of ecosystem management approaches that may be more or less appropriate given the landscape dynamic context, so restoration activities, for example. And one thing we're certainly seeing is that the variety of metrics we're developing are useful for modeling resources of concern, but we're also starting to see that they could be potentially very useful, for example, for distribution modeling for individual species even. And there's really just a variety of applications that we see moving forward. So in terms of project deliverables, we definitely intend to make the full library of raster spatial data available along with the resilience / vulnerability spatial models for targeted resources like carbon storage that we're working on now, but we definitely are also moving on to some of the other important ecosystem service models that I mentioned early on with regard to water and outdoor recreational use. And then over the long haul, where we're really trying to push this is into a web tool context that we're calling LandDat. So a new set of tools, that's landscape dynamics analysis tools that are made public with the full data library, but also with case studies and narrative descriptions that really describe what other people will be able to do with the new tools we're developing, making it all available for download and et cetera. So what we really hope is that what we're doing isn't just our own sort of a few vulnerability models that will be useful in themselves, but limited with regard to what could be done with the new resilience metrics, but making those more widely available so that other people, maybe other LCCs or other within the LCC conservation partners who have different questions and see maybe the utility of what we're offering for their own work or their own questions, that those will, the tools are made available widely to partners and stakeholders. So I'm going to leave it at that, and let me see. I think we're still roughly running about 5 minutes late, but that wraps it up for me, so I'll just leave it at that for now. Thanks.